Hello, welcome to Geometry Unit 1, Section 1. This is Mr. Zacek, and we're going to begin this year by looking at some definitions and things. So you should have your Unit 1 note packet out now as we're going to go through this. And feel free to write some notes down, questions that you have as we walk through this. We're going to look at some definitions here to start. And then we're going to kind of get into a few different things that we have to know and then put it into practice. But this is about understanding vocabulary and recognizing things. And the tip of the day today is pay attention to if the letters are capital or lowercase. And that will make a difference, and we'll be referencing that. So we're going to start off with three terms that are the basic ideas used to build all the definitions for figures and geometries. And those three terms we see right here are point, line, and a plane. So we have point, line, and a plane. And the first one is a point. So a point indicates a location and has no size. Now, I want you to note that there's no size for a point, but we represent it by a dot, and it's named by a capital letter. So we can't make a dot that has no size, but technically a point actually has no size. So when we see a point, we're going to use a dot, and we're going to use a capital letter. In this case, we have the capital letter P that is being used for it. Now, a line is a series of points that extends infinitely in two opposite directions. It has no thickness. So in order to have a line, we have to have at least 2 points. That will be a key on the line. So we can use that when we're naming. I want you to notice here that we have arrows on both sides of this line here. Arrow here, arrow here. And here are the two different notations. So this is a notation. I'm going to figure this penmanship stuff out. I'm using a little tablet here, so I'll get better at it as we go. That's a notation, N. So we have two capital letters, line, and notice the arrows on both sides. Or we could write the word line with a lowercase l here. And very often, so we don't confuse it with the number 1, we do a cursive lowercase l, which is written kind of like that. All right, so we've got point, we've got a plane, a line, and now we are going to look at a plane. So a plane is represented by a flat surface that extends without end, has no thickness, and there are infinitely many lines. Note that there in a plane. So there's a no limit to the number of lines. We kind of use this diagram here in red as a representation of a plane. Now, obviously, this ends, but we want in our minds to think that this continues for forever. So often in class, I'll be talking about the walls or the ceiling or the floor as a representation of a plane, but we want to keep in mind that it extends. So over here, we have our notation. So we can represent a plane a couple different ways. One way is we can use 3 points that are not on the same line. So A, B, and C, any 3 points. And notice that all of those have a little dot to represent that they're points. Or this letter N up here, just notice that's not representing a point because it doesn't have a dot next to it. So we could use the letter, a single capital letter, and that's how we can represent a plane. So those are three fundamental concepts. We've got point, line, and plane. Next part here is collinear points. Collinear points are points that lie on the same line. And let's think about just this prefix co here for a second. Co. Cohabitate means live in the same place. Coexist, we all exist together. So collinear means points that are on the same line. So we have collinear, and then we have non-collinear points. So if points are non-collinear, there has to be 3 or more points that do not lie on the same line. And this over here is our example. Whoops, sorry for the crazy highlighting. Getting used to this board. D, E, and F. Those are non-collinear. Moving along here, we have this idea of coplanar. Coplanar are points that lie in the same plane. Sometimes I sing this little song, 1 point, 2 point, 3 point, same plane. Coplanar, 1 point, 2 point, 3 point, same plane. Coplanar. So I don't know why I sing that, but I do. So if we have 3 points that are in the same plane, we call those coplanar. Space is not the final frontier, but is the set of all points in 3 dimensions. That's what we think of as space as geometry students. And now we have, excuse me. The next part is these 3 words. So we have a line segment. Let's talk briefly about what is a line segment. So a line segment is part of a line that has 2 endpoints. Okay, so let's underline 2 endpoints, and it's all the points in between them. So we have MN here is a line segment. Now notice that when we write the notation of MN, that we do not put arrows on it. So here's where kind of the vernacular language and geometry differ a little bit. Often, like when we have a fire drill, we'll go outside and your teacher will say, line up. Well, we're not really creating a line. It would be more accurate from a geometric standpoint to say segment up. So we are lining up in a segment, which is a part of a line, but it has a definite endpoint. Now, the next thing, similar but slightly different, is a ray. And you'll notice here, ray AB. And with ray AB, ray has one endpoint, and then it extends indefinitely in the other direction. Now, crazy line again. Note this, when you're naming a ray, the first letter, let me see how well I can write this. First, that's crazy. Hopefully we'll get better. The first letter is the endpoint. Feel free to write this more neatly on your own paper. So the first letter is the endpoint. So this is ray AB, and see if we can clean that up there. Whoop. A little big on the eraser side. So this is ray AB. Ray AB, again, when we're writing it with the notation, we write it with the endpoint first. It doesn't matter if it's being drawn in a different direction, which we'll see in the next one. So opposite rays are 2 rays that share the same endpoint and form a line. So this is going to illustrate what I was just talking about here. See how the letter C comes first? CA is the ray that goes from here through that point, and then CB is a ray that goes from here and goes through that point. But notice, so they're drawn in different ways, but the way that we write them with the notation is both of them start with the letter C because that's the endpoint. And so the way you write it notationally is not based on the direction that it's drawn on your paper. All right, so we're cruising along, lots of words here, so we're going to move through them. We'll practice some of these here in a little bit. A postulate or axiom is an accepted statement of fact, and that's basic building blocks used to prove concepts. So if we have a postulate, when we hear that word, we want to be thinking, okay, this is something that is an accepted fact, not something that we need to prove. Oops. I got to get my formatting here back. Okay, thanks for being patient with me while I figure some of this stuff out. Okay, so as we look at page 2 here, each one of these starts with this question. So here is our question that we have right now, and I'm just going to highlight what that question is. How many lines can be drawn through these 2 points? So if we draw 2 points, how many lines can we draw through these 2 points? And the answer to that question is on our paper here. It's written for us. You don't have to write it out. Through any 2 points, there is exactly 1 line. So here's the connection that we want to make if we just want to simplify this really briefly. 2 points. create one line. And again, we could name this line up here. We could name it AB with using capital letters and with the line symbol across the top. Or we could write the word line and L. So through any 2 points, we create one line. 2 or more geometric figures, okay, their intersection is the set of points that they have in common. So let's see this. Draw 2 distinct lines that intersect, and I've done that already. I'll put the arrows on them to indicate that they're lines. And we can see very clearly that what is the intersection of these lines? Well, they intersect at a point. Let's call that point P. So any 2 lines, 2 distinct lines, they're going to intersect at one single point. Okay, so that's what's being said right here. If 2 lines intersect, then they intersect in exactly 1 point. And again, that point here would be point E on our on this screen right here, point E. Okay, so now 2 lines intersect at 1 point. That's the idea of this postulate, something that we accept. The next thing we're going to do is we're going to draw 2 distinct planes that intersect. And what is the intersection of these planes? Now, you know, lines are something we're more familiar with. Planes, it's a little bit harder for us to visualize. So when you think about planes, what I want you to think about is like the floor intersects the wall. Let's just kind of get a visual, like some kind of picture that we can keep in our mind. So what is the intersection of these planes? And we have a picture of what that looks like over here. If 2 distinct planes intersect, then they intersect in exactly 1 line. So that line that's going through right here, this is like, where does the floor and the wall meet? Well, they meet and they form a line. So we have one exact line. Okay, so 2 lines intersect at 1 point, 2 planes. So let's kind of write that out. This is just the quick summary of the idea. Intersect. So 2 planes intersect at 1 line. And the word distinct is important, meaning they have to be different planes. They can't be parallel planes. We'll talk about those things to come. All right, draw 3 non-collinear points. Now, so when we have 3 non-collinear points, like how many planes contain all 3 points? So how many planes can get all 3 of those points through any 3 non-collinear points? There is exactly 1 plane. So this red diagram here where we have A, B, and C is an example of that. And we would write this as plane, P-L-A-N-E, A, B, C, capital letters. Okay. Or we could write this as plane N. Okay. So how many planes contain 3 collinear points? Well, if the points are all on the same plane, then that is actually, it's an infinite number of planes. So if you have a line, there's an infinite number of planes that can intersect that. Now, some of you might be like, how can that be infinite? You know, doesn't it take... And you have to remember that a plane doesn't actually take up any space, nor does a line. So when we think about those, they don't take up any lines. All right, let's go through some practice here. See if we can just kind of zoom this out pretty quick. Name the line below in 2 different ways. Okay, so let me get my pen here. Let me just get it so it's a little bit not quite as thick. I think that'll help me write a little bit better. So name of the line below in two different ways. Well, we could name this one way. We could name this as we could name it line J, K. All right, with arrows. We could flip that around and we could name this line K, J. Now we don't have any like lowercase letter attached to it, so we can't use that method. But we can do that down here in number 2, name the line below. Well, we don't have any points on the line, so we could write points. That would be one way to do it. Or we could just call this line N. Notice that's a lowercase letter, whereas in number 1 we have capital letters for represent the points, and we use the arrows. Okay, name the line segment below in two different ways. Okay, line segments, we have to use the endpoints, so AB, or we could call this BA. Now, if you had another point, like maybe you had some point in the middle like M, you could also call that line AMB, line segment, excuse me. And that would not be wrong. That's another way. You can use more points, but you only need 2. Okay, name the ray below. All right, so this ray is going to be RS, and I want you to recall what we had remembered before, that you only use, it always starts with the endpoint, and this, there's only one way to name this. You can't switch this around like you could with a line segment or a line. Okay, whoops. Name the plane below 7 different ways. Wow, that's a lot of ways to name a plane. So let's see what we can do here. All right, plane. Well, one is we could just use this letter B right here. That's, again, that's not a point. That's just a letter that we have out there. So we have plane B. Well, then we could name it plane JKL. And we could name it plane. And basically now those are all 3 non-collinear points, and we could just move these around. LJK, plane. Okay, so we got JKL. We could go with JLK, plane. JKL, JLK, LJ. We could do LKJ. So we've started, 2 of them start with J, 2 of them start with L, and then the last 2 would be ones that start with K. So KLJ or KJL. The point is, the order of the letters doesn't really matter here. You just need 3. And we could do more than 3. We could do 4 letters. Sometimes when we start drawing like boxes or rectangular prisms, you'll see it done that way. Okay, number 6, name the 2 opposite rays below. So again, here with a ray, opposite rays, the key to opposite rays is they both share the same endpoint. So in order for these to be opposite rays, we have to start with the letter EF. We're only going to use 1 arrow, and then ED. In order for them to be opposite rays, they both have to start with the same letter because they have that line. All right. So down here, EF and FE, those 2 rays, ray EF, this one right here, and ray FE form a line. Are they opposite rays? Well, the answer to that question is no, because they do not share the same endpoint. And in order to be opposite rays, they have to share the same endpoint. So they do not share the same endpoint. Okay. All right. Now we're going to match some of these. So this here is what I was talking about when I said when we have like a rectangular prism. Here's kind of a classroom type scenario that we can think about to help us match it up. So first of all, we have plane. A says plane HGE. So let's figure out what is plane HGE. And plane HGE is actually what I would call like the bottom of this box. Now it includes F, but we only needed 3 points to do it. So a plane, could we name that another way? It's plane, it's going to be down here to J. It's the plane containing points E, F, and G. So all of those points you see are in there. Okay, let me get a different color now. Now we have BF. So what is BF? BF is this kind of line right here. A little hard to get that straight. Well, what is that? BF is a line, if you remember from before, is the intersection of 2 planes. So it's the intersection of this plane over here, ABF, which again contains E. You see that one? And CGF, this one down here. So what I like to tell people is, if you're doing a test or working on an assignment, it's good to draw those in. You can see that, yeah, look at that. Both of those, they intersect here at this line BF. Okay, plane DAE. My guess is, let's get another color here. Come on. Whoops, sorry. Green. So plane DAE, that would be the front of this box. It's actually DAE, but it's going to contain H as well. There. And look at that, AEH. So that's going to match up over here with this one. Okay, line Y. Let's take a look at where line Y is down here. You probably have got it before me. This looks like line Y. Okay, so where is line Y? A line through points F and E. So it was named with a lowercase letter, but those are the points that the line has gone through. And then obviously the last one here, point A, is the intersection of A, B, and line Z. So that's what we talked about before, that a point is the intersection of 2 distinct lines. So if you have 2 distinct lines, they intersect at a point. Okay, now let's move on here and let's see if we can just kind of finish this here. So each surface of the box at the right represents part of a plane. What is the intersection of plane ADC and plane BFG? So we have ADC, that's this plane up here. I like to kind of highlight it. ADC and plane BFG. This is where good to have some highlighters. BFG. Well, that's going to come up to C. What do they have in common right there? Well, that would be line BC. Now remember, planes intersect at one line. So we want to make that a line. We want to put those arrows on. What are the names of 2 planes that intersect at BF? So let's come over here now. BF is this line right here. And again, keep in mind that's really actually going to extend all the way. Well, we can think of this like the front of the box and this side here. So I'm going to name these a little bit differently just to show that variation. We're going to call this plane, I'm going to call this first one ABFE. I'm actually going to use 4 letters. And plane, what would that other one be? BCGF. Now again, you only need 3 letters, but we could also do it with 4. It's not wrong to do it 4, so I just want to show you can do both of those. So again, that's plane ABFE and plane BCGF. All right, what plane contains the points N, P, and Q? Well, let's go over here. Okay, N, yeah, P, Q. That's kind of the bottom of the box here. So, yep, okay, let's shade that in there. Yeah. There we go. And we would name that plane. There's a whole host of ways we could name it, but we're going to name it plane R, Q, P, N. And again, we could have named that with 3 points. All right, B. What plane contains points J, M, and Q? Okay, so J. Now, here's where I want you to star this one, because this is where people start to have a little bit of, whoops. Let's undo that move there. Okay, here's where people start to have a little bit of trouble, this one. And M, J, Q. Q is down here. Now, that's not the front of the box. That's not the side of the box. That's not the top. This, however, is diagonals. So this is how that is also a plane. Remember, there's an infinite number of planes happening here. So almost any way that we could rotate this, we could create that plane. So that would be, just kind of shade that in a little bit here. That is a real tricky one that people have a hard time with. So let's name that. We'll call that plane J, M, Q, P. And once you learn to look for it, it's not so confusing, but usually just initially that can be a little bit tough for people. Okay, what plane contains L, M, and M? So we've got L, M, and N. And here we are again. That's this one right here. So L, M. Now that's not the top of the box because N comes down here. So it's kind of this little diagonal slice that we have right through there. And I'm not going to shade this in. Okay, now these reflection questions, I'm actually going to have you complete these on Buzz and bring them in that way. And so nice work. That completes lesson 1. Great job.